Hi guys, today we are looking at component marrying so that we can actually get a component that we are going to be using in your schematics and PCBs. Now, up to now you've created symbols and you've created patterns, and we now need to create the physical component. So the first thing you would need to do is you need to open up a library executive. Then here under default library set, right click, add library, and you choose your library that you have created, where your symbols and your patterns lie. It's noteworthy that I need to bring your attention to it that the library that you are going to be working on to create the components needs to have both the symbol and the pattern in that specific library. You cannot create a component by linking the symbol from one library and the footprint from another library. It doesn't work that way. You need to have both symbol and footprint in the same library, and then you can create that component in that specific library. So go and add your library. Then basically what you'll see is you'll get a loading like this. Now in my case I've just added a few library components because I'm going to do two components as in this example. So first of all we need to go component, new. We choose the library that we want to store the component in. Next we choose pattern. We choose the TO220. Next we select symbol. We choose the symbol. And then we go pin view, pattern view, symbol view. Now your windows might not look exactly the same, so you need to scale them. As you can see, you can scale them. You need to scale them in order to see all the windows on your screen. It's pertinent because you're going to need all the information. Secondly, you need to take the data sheet and you need to mark your pins how you want them to be in the end of the day. So as you know, if you look at a TO220, if this is the physical package, I said to you guys the normal naming convention is to say this is pin 1, that is pin 2, that is pin 3. So this is what I've marked down here on the side. Also we need to marry our symbol to look like that. So as you can see, by default the pin numbering is not correct, so we are going to go and fix this now. Okay, let's get going. So first of all is the pad number column that I've highlighted here. These are the pad numbers that you see here. Okay, now you will see that there's a 1 and a 3 and a 2 and not a 1 and a 2 and a 3. The reason for that is it's because of this pin designator. So I'm just going to remove it for now, and now you'll see it's pin 1, pin 2, pin 3. So that's the correct naming convention that we want. Next of all, let's look at the symbol pins. These symbol pins, pin 1, that should be pin 3, that's correct because that's the input, and pin 2, that is the output, so that is absolutely correct. So there you can see pin 1 is adjust, that is correct. Next, pin 3 is the input, that is correct, and pin 2 is the output, which is correct. So now we need to make sure that we marry the correct pin to the correct symbol pin. So the best way is to click on the left hand side here. As you can see, you highlight in cyan, you highlight the correct pin number, and it will automatically show you both in the pattern and the symbol which pin PCAD things you are now referring to. So I'm using this as a safeguard and a check to make sure that I use and I map the correct pin. So let's start with pin 1. So we know that is the adjust pin. On the symbol, that is the adjust pin, that's correct. And it must go to the footprint, pin number 1. So what is the pin designator we need to assign there? It's a 1. Okay, let's look at the second one. We have this as the input. So the input, which is pin 3. Okay, so we know that pin 3 must be mapped into the input. Now, as you can see, currently this is not done correctly, and that is because when you loaded the part, PCAD went and chose the wrong pins for the mapping. But that's not an issue. Let's fix that. So here by symbol pin 2, we should have a 2, and by 3 we should have a 3. So by 2 we type in output, and by 3 we type in input. Okay, so now it'll be correct. So pin number 2 is the output. On the symbol it's the output. On the footprint it's pin 2, it's the correct pin. So what is the pin designator? It must be a 2. And by implication, that will be number 3. So let's go and double check it. Pin 1 is the input. Oh no, sorry, pin 1 is the adjust pin. Pin 2 is the output. And pin 3 is the input. The last thing we need to do is you need to set the gate equivalency. Now this gate equivalency comes from if you use a multi-gate component. In this case, we only have one symbol. So we are only using one gate. So as you can see here, number of gates 1. So when you type in 1 here and you press enter, it will populate all those fields with gate equivalency of 1. I'm going to show you now an example where just after this symbol, where we are going to have a multi-gate component and then things change a bit. Okay, so there we go. So we've done that. In this window, we must just say the reference designator, so that's U for IC. And we can click here on the top, validate, and we found no errors. At this point in time, you can click save, and you can type it LM317. And what I do is I make an underscore, then the footprint, which is a TO220, and I know that you get the horizontal mount version and the vertical mount version, so I'm going to differentiate between the two. So I'm going to say here, this is the vertical option. So there you go, you've created the LM317 TO220 vertical. If you click OK, if you right click here on the library, on the physical library, and let's just see here, and we say reload. So you click on the default library set and you say reload, then you'll see there's a plus that appears, and there's the part that we've created. Okay, so this covers the creation of a TO220 package. Now let's have a look at an alternative component. Okay, so here, let's just get hold of this. There we go. Okay, so let's go and create a quad NAND gate. Okay, so let's start again. Again, this is copied from the data sheet. I'm choosing to make this in SOIC 14 package. This could have been the DIP package as well. It's got the same pinout convention. Okay, so let's get going. We go component, new. We choose the library we want to make it in. We choose the footprint we want to use. Next, we need to do something very important. Before we go and select the symbol, we need to make sure that we set the correct number of gates. Now, how many gates are in here? There's 1, there's 2, there's 3, there's 4. So here under number of gates, we type in 4. What's the designator? U. Okay. Next, you need to look down here at the bottom, and you need to look here. Component style, homogeneous or heterogeneous. Homogeneous means that all the symbols in the component will look exactly the same. Now, I like having two types of symbols, especially for gates, op-amps, buffers, all those devices where you'll typically have between 4 and 8 devices in a package. And I will create them with a power and a ground on the one, and then the remaining parts won't have a power and a ground. So in my case, it cannot be a homogeneous, it needs to be a heterogeneous. So it means it's got symbols that looks different. So let's get going on this. So here under gate A, we can double click on it and we say, okay, we want a NAND gate with a power and ground. There's the power and ground pins. We click OK. Next, we need to say the one without the power and grounds. So I just go and assign for each gate, I just assign that. And here under gate equivalency, you need to say 1, 2, 3, 4 because there's 4 gates. Next, we do the same thing again. We go pin view, pattern view, symbol view. Okay. Now, what I want to suggest is at this point in time we remove this from here and let's go and assign it ourselves. So pad number 1, which is this pad, that needs to go to the A0 input of the NAND gate. So let's go previous symbol here until we find the one that looks like this. As you can see, it's symbol view 1. The one there at the top, that's the one that you see here as well. So that one and that one, that's the link. This is the first pattern we want to use. Okay, so we have pad number 1, which obviously is going to be the same, so we can type these numbers in. So both pad number and pin designator needs to be the same, otherwise things get very confusing. So let's just type this in here. So now we know that these pads have been numbered the same way as the pad number has been numbered. So the pin designator and the pad number is the same, and as you can see, it's now, instead of red, it's white. So that has been assigned. So as you can see, it follows the correct numbering convention, with pin 1 on your top left hand corner going anti-clockwise to number 14. Next we need to say, okay, now which symbol pin does pad number 1 equate to? Well, that's easy, it's A0. So it can be either one of these two, so let's just choose pin 1 to be that correct one. And number 2, we need to take to symbol pin number 2. So it's these numbers that I type in here. What is the name? That is A0. What is that name? It's B0. Okay. What gate will this fall under? It'll fall under gate number 1. So pin 1, pin 2, and pin 3 falls under gate number 1. Also, because this is the power and ground pin, I will assign pin 7 and pin 14 to gate 1 as well. So under pin 7, a 1, and pin 14, a 1. Okay. Next, let's look at the output. So the output of the NAND gate goes to pin 3. There you can see pin 3. Which symbol pin is it? It's symbol pin number 3. So we type in a 3 there and we say it's O0. Okay. Let's assign the power and ground. Ground is pin 7. There you can see. You see pin 7. Symbol pin number 5, and we say that is ground, so we type in ground. Here we say symbol pin 4, we type in there VCZ. Okay, so there you've assigned your first symbol. Now we say here next symbol. As you can see, 2, we are now hereby 2. So the second gate, we have A and B on 4 and 5. So we say 2, 2, 2, and we say here symbol pin number 1, 2, 3. Okay. Here we say, what is the name? It's A1, it's B1, it's O1. Okay. Then we can say next symbol. That's the third gate. Where's A and B? At number 10 and number 9. So number 10, to be consistent, so I make it 3, 3, 3. So number 10 I assign to symbol pin number 1, okay, which is A3. Number 9 I assign to symbol pin number 2, which is B3. And we assign symbol pin number 8 to O3. Okay. Let's just go previous symbol, next symbol, then you can see it properly. Sometimes Altium does this, so this is just a bug. Okay, so here you can see pin 8 is the output, B3 is number 9, and number 10 is A3, so that part is correct as well. Okay, let's next symbol. Here's the last one, A2, B2 is number 13 and 12, so number 13, so we just say 4 there, so number 13 goes to pin 1, number 12 goes to pin number 2, and number 3 goes to the output. Okay, so again we say 13 is A2, here's B2, and here's O2. Okay, let's go and check if what we've done is correct. Again, I'll make sure that I click here on the top. Let's go and double check it. So pin number 1, there's pin number 1, goes to A0, which is correct. Next, B0, next, output 0. So gate number 1 is correct. Then and as you can see, as I move from the one to the other, it changed the symbol automatically. So number 4 is the A1, B1, output 1. Then we go jump back to the first symbol, there's the ground, then we jump to the third gate. So pin 8 is the output, followed by B3, followed by A3. Okay. Next, 11, which is the output, followed by the B input, followed by the A input, and lastly, the power. So we have now correctly assigned our mapping, but there's one thing we need to still do, and that will facilitate you when you go and use the component in your schematic and your footprint and your PCB, and that is the inputs of your NAND gate can be swapped around. It would not make a difference in your operation. So let's go and swap. Let's tell PCAD that whatever net you assign to pin 1 and 2, if it facilitates that the routing will be better to make this or swap these two pins around, it's allowed to do that. And this is what we specify here under the gate equivalency. So by A0 and B0, we will type in gate equivalency of 1. Okay? Here, well, that's the pin equivalency, I apologize. For the pin equivalency, pin number 1 and pin number 2 can be swapped around. So here we'll say pin equivalency of 1. There you go. Let's look at the next symbol, pin 4 and 5. So pin 4 and 5 again. So we say here 2. As you can see, every time you type in a number, it tells PCAD that those two pins are interchangeable with each other without causing any interference. So PCAD will, if you tell it to do it, it will automatically do a pin swapping on your PCB. So put that in your part, then at least you have functionality once you are busy routing your board. So look at the third gate. Third gate is number 9 and 10. So number 9 and number 10 will go to pin equivalency of 3, and the last pin is 12 and 13, which will be 4. Okay, now I got a bit confused here. Under the gate equivalency, all the gate equivalency then in this case means is that you can swap this NAND gate with that NAND gate, or this NAND gate with that NAND gate, or you can swap this one with that one, or that one with this one, or whatever way you would like to do this. So we need to tell PCAD again, you can use any of the gates because these gates are all the same, again, to facilitate your routing of your board. So gate equivalency 1, there you can see it ties into the 1 that you see there. Then this one, you see there's 2, so we type in 2 there, it will populate those. 3, we type in 3 there, and 4, we type in 4 there. So now what it tells PCAD is that you can swap gate 1 with gate 2, or gate 3, or gate 4 with each other. And under the pin equivalency, we say you can go even further. You don't just need to go and swap around the gates, you can actually swap around the pins as well. And then we define, okay, which pins can you swap around? The A and the B input you can swap around. Obviously, you can't swap the A or the B with the output, for example. You can't do that. So the inputs you can swap around, and some of the logic gates you can, and some of the logic gates you can't go and swap around the pins. So you need to make sure that looking at the truth table, make sure that you have correctly assigned this table. Otherwise, you can possibly end up with errors on your PCB. So this is the purpose of the pin equivalency, to swap around the pins. The gate equivalency has got to do with swapping around the gates. So by this, we can now go and verify that the component is valid and it doesn't find an error. And at this point in time, we can save this and we can call it the 74HC00 underscore SO IC14, because that's the package number and the part number, and we save it. Okay, and as you can see, it's created the part. We can just again go and reload and it'll populate it. You'll see there's a red little dot there, which means the component has a symbol, and it's got a blue outline here at the back which says there is a pattern assigned to this component as well. So you need to see both the red and the blue in your component view here, and then you'll know that that component has been absolutely correctly created. So by the end of this exercise, you are able to create a homogeneous component and a heterogeneous component. In this case, a multi-gate NAND gate and a LM317. Thanks, guys.